Hi everybody, in this video, let's learn one of the features of this calculator, which is prime factorization. Let's do a quick revision about prime number. I hope that you still remember what is a prime number. A prime number is a whole number. You don't have to think about decimal or fraction because prime number is a whole number which is greater than 1 and it only has two factors which are 1 and itself. So remember, 1 is not a prime number. And the first prime number is 2. Remember this 2. This is a quite special prime number because this is the only prime number which is also an even number. The rest of the prime number are odd number. Let me list out first few prime number for you. 2, 3, 5, okay, these are first few prime number. You will notice that all of these are odd number except this one even. So remember, so 2 is the first prime number and 2 is the only prime number which is an even number. The rest of the prime number all are odd number. Okay, why do we say that 17 is a prime number? Let's see, how many factors does 17 have? 1 times 17. Do we have other factors? No. Therefore, 17 is a prime number. It only has two factors, right? Okay, so how about 27? Is this a prime number? This is an odd number, right? But is this a prime number? Not all odd number are prime number, so you need to be careful about this. 1 times 27. Do we have other factors for 27? 3 times 9. Oh, now we know that 24 has 4 factors. Therefore, 27 has 4 factors. Therefore, 27 is not a prime number because prime number can only have 2 factors. Okay, let's look at some others number. 2, 4, 5, 6, 8. Is this a prime number? We don't have to list out all the factors of this number because it takes time. This is quite a large number. We just look at the digit at the back here, then we know that whether this given number is a prime number or not a prime number. If the digits at the back here is 0, 2, 4, 6, and 8, this number is definitely an even number, means that it can be divided by 2. And just now I told you that all the prime number are odd number except the 2 here. This is not 2, right? So therefore we can make a conclusion. This is an even number and this is not 2. So we can make a conclusion that this number is not a prime number. Let's try another example. Seven, 9, 3, 8, 5, 7, 5. Okay, this is quite a big number. So can you determine whether this number is a prime number or not a prime number? You look at the back here, you know. If the digit at the back here is 5, we know that this number definitely can be divided by 5. And just now I told you that prime number only has 2 factors, which are 1 and itself, right? So this number definitely can be divided exactly by 1, and definitely it can be divided by itself. But it can be divided by 5 also. Now we know that this number has more than 2 factors. We don't have to know how many factors does this number have. As long as we know that this number has more than 2 factors, then we can make a conclusion. This is not a prime number. not a prime number. Okay, let's try others number which are a little bit hard for us to determine whether it is a prime number or not a prime number. Before this, let's talk about prime factorization. So let's say, let me give you a smaller number to show you what is a prime factorization. Let's look at 80, let's say, 80. If you want to do prime factorization, we can use factor 3, right? Or we can just use repeated division. Divided by 2. All the number used here must be prime number because now we are doing prime factorization. So 80 divided by 2, you will get 40. 40 divided by 2, you will get 20. Every time you need to use prime number because now we are doing prime factorization. Now 5 cannot be divided by 2, right? So we need to use another prime number, which is 5. Okay, so 80 is equal to 2 times 2 times 2. How many 3? How many 2? 1, 2, 3, 4. 4 times. And times 5. This is prime factorization. So when the number becomes larger and larger, it will take time for us to do the prime factorization, right? But this calculator can help us to do the job. Now you see this FACT, which is printed in yellow color. Now let me show you how do we use this calculator to help us to do prime factorization for 80. First, you just key in 80 first and remember to press equal. Now we press shift first because we want to activate this button printed in yellow color. We need to let our calculator know that we want to press this, not this degree. Shift first and press this. Now your calculator can help you to do the prime factorization 4 times. 1, 2, 1, 2, 3, 4, 4 times, and then times 5. Okay, this is one of the very useful features of this calculator, which is prime factorization, especially when the number becomes very large. We want to test whether the number is a prime number or not. It's very easy to use this calculator to test. Now let me show you. So definitely 80 is not a prime number because you can separate it to a few prime number, right? So if the given number is a prime number, for example 23, this is a prime number, right? So when you use your calculator to do the prime factorization, you will see this. Now let me show you. 23 equal shift. The calculator doesn't do anything for you because this is already a prime number, right? So we cannot say 1 times 23 because 1 is not a prime number. So therefore the calculator will not show you 1 times 23 because 1 is not a prime number, right? So the prime number, the 23 is already a prime number. So if you see, after you press the shift and this prime factorization, your calculator doesn't change the number form, just give you back this number, original number, then the number is a prime number. Okay, now let's test these two. This is quite a big number, right? So if you want to do prime factorization, it actually take time. Now 8, 9, 2, 9, press equal, shift, factorize. So we are using our calculator to help us to do the prime factorization. You will notice that this number doesn't change, right? Let me show it again. 8, 9, 2, 9. Press equal, shift. It doesn't change. Then we can make a conclusion that yes, this is a prime number. How about this? Let's try. 8, 3, 7, 9. Press equal, shift, prime factorization. Oh, now from here we know that the prime factorization for 8379 is equal to 3 square means 3 times 3 times 7 square, 7 times 7 times 19. Therefore, we can make a conclusion that this number is not a prime number. Okay, or you can take a try. 3 square times 7 square times 19, you will get 8379. Okay, so this is a way how we use our calculator to help us do the prime factorization. Okay, next I want to share with you is the highest common factors. Since the way how we get highest common factor and lowest common multiples are quite similar, so in this part I'm going to show you the difference between highest common factors and lowest common multiples. So in the next video, I will focus on lowest common multiples. Now, let's do a quick revision. How do we find highest common factors? We have three methods, right? Listing, repeated division, and prime factorization. These two, we also can use this three method. Let me show you listing method first. Okay, now I'm using listing method. This will take a very long time if the number is very big. 1 times 30, 2 times 15, 3 times 10. Okay, so 4 cannot, 5 cannot, it will be, the next will be 6. 6 times 5. Oh, sorry. 4 cannot, 5 can. 5. 5 times 6. Okay, the next will be 6 times 5. Whenever you see repeated pair, 5 times 6 and 6 times 5 is the same thing. So you don't have to continue thinking again. So that's all. That's all the factors of 30. Now 40. 1 times 40. 2 times 20. 3 cannot. 4, yes, 4 times 10. 5 times 8. 6 cannot, 7 cannot, 8. 8 times 5. Now repeated pair, right? So stop here. These are all the factors of 40. So what is the highest common factors? The largest common factors are the largest common factor, yes. So when we just talk about factors, common factors, these are all the common factors. Common factors. Okay, means that 1, 2, 5, 10 are the factors of 40 and also are the factors of 30. That's why we call this highlighted number. They are common factors of 30 and 40. But now we want highest, largest. So the answer will be 10. Highest common factors of 30 and 40 is 10. So this one called listing method. So let me show you repeated division. We normally like to use repeated division. It's quite handy, easier for us to get the highest common factors. Repeated division. Okay, 30, 40. So sometime if you want to do prime factorization like what I showed you just now, you need to use prime number. For highest common factors and lowest common multiples, you don't want to use prime number is okay, but you need to be more careful because some teachers they only want you to use prime number. If your school teachers want you to do so, then you have to follow. So for this case, right, if I want to start by 10, it's okay actually. I will still get the same answer. But some teachers they don't want you to do so. Maybe they worry that you will mix up this and this. because for prime factorization, you definitely need to use prime number. So for this, if you don't want to use prime number, it's okay. But if your school teachers or if your teachers want you to use prime number, then you have to follow him. Okay, here I will show you use a prime number first. 2, 15, this is 20. 30 divided by 2, you get 15. 40 divided by 2, you get 20. Now these two numbers cannot divided by 2 anymore. So the next common factors will be 5. Now 3 and 4 don't have any common factors anymore except 1. So we don't have to divide by 1 because if you divide this two number by 1, you do the same thing. You will get the same number, right? So we can just stop here. Therefore, the highest common factors, okay, let me use back red color. The highest common factors is equal to 2 times 5 is equal to 10. Let me show you last method, which is prime factorization. Okay, let me write over here, prime factorization. Okay, if this now we are doing prime factorization, right? Therefore, we need to use prime number. This time you must use prime number. If you use 10, then you will get 3 times 10, you get 30, right? Okay, so you say 30 is equal to 3 times 10. This is not prime factorization because 10 is not a prime number, right? Okay, so divided by 2 first, 15, divided by 3, 5. 5 times 3, you will get 15. Now divided by 5. Okay, 2 times 3 times 5. How about 40? Same thing. We do the prime factorization for 40. 40 divided by 2, you get 20. 20 divided by 2, you get 10. 10 divided by 2, you will get 5. 5 divided by 5, you will get 1. So it will be 2 times 2 times 2 times 5. Okay. Let me erase this one first. Now we look at common number. 2, 2, and we have 5, 5. So the highest common factors will be the multiplication, the product of these two numbers. 2 times 5, which is equal to 10. You will notice that no matter what method you use, all will give you the same answer if you do it correctly. 10, 10, 10, and 10. Normally, we like to use this method. Okay, now let's look at this one, LCM. So you have to be more careful. Same thing, we have 3 methods for this: listing, prime factorization, and repeated division. But the way how we get LCM slightly different from this. Okay, let me show you listing method first. Listing. 30, the multiple of 30 will be 30, 60, means that 1 times 30, 2 times 30, 3 times 30, and so on. Okay, I just stop here because it's impossible for us to list out all the factors of 30 because the factor of 30 is go infinitely. Okay, how about the factors of 40? We just need to list out few. Okay, from here you know that the lowest common multiples is 120, right? 120. This is listing method. How about repeated division? Okay, same thing. The beginning step is the same with the highest common factors, but this time you have to be more careful. Okay, so as I told just now, if you want to straight away divide it by 10, it's okay. But if your teachers don't want you to do that, he want you to start with the prime number, then you have to follow your teachers. Okay, let me start with prime number. 30 divided by 2, you get 15. 40 divided by 2, you will get 20. Now, it can be divided by 5, right? Okay, so you see, the same method, same step, but we need to proceed. For LCM, whenever they don't have the common factor, it's okay. You just take the 3 divided by 3. 3 divided by 3, you get 1. So how about 4? This 4 cannot divide it by 3, right? So you just bring the 4 down, pull the 4 down. Okay. Then take this divided by 4. 1 cannot be divided by 4. It's okay, you just bring down the 1. We want to see all the number become 1, then we stop. So 1 cannot divided by 4, it's okay, you just bring down the 1. 4 divided by 4, you will get 1. Okay, now only we stop. The LCM will be 2 times 5 times 3 times 4. Okay, so if you don't want to divide by 4, because you might be thinking, oh, teacher, 4 is not a prime number. I want to divide 2 times by 2. It's okay, you get the same answer. Okay, 120. So let me show you. Let's say if I don't want to use prime number, I don't want to start with prime number, can I still get this answer? Yes. So let's say I want to be faster. I divide these two numbers by 10. You will still get the same answer. 10 times 3, you get 30. 30 times 4, you get 120. But if your teachers want you to use prime number, then you need to follow, okay? So don't mix up these two because they are step quite similar. For HCF, we stop here. Whenever they don't have common factor except 1, so we just stop here. So for LCM, if we don't have any common factor except 1, we can just bring down the number. Like for example, this 3 and 4, here we stop, but for LCM we still continue. Divided by 3, 4 cannot divided by 3 is okay, you just bring the 4 go down. Then as long as once we get 1, we don't have to do it anymore, we just keep on pulling it now. Now 4 divided by 4, but 1 cannot be divided by 4, it's okay, you just bring the 1 go down. 4 divided by 4, you get 1. So until you see all number become 1, then only we stop. 2 times 5 times 3 times 4, you will get 120. Let me show you last method, prime factorization. Okay, so I just copy this one. 2 times 3 times 5. So 40. 2 times 2 times 2 times 5. Okay, this one you have to be more careful. How do we get LCM? Slightly different from this. This is same number, right? If you see these two numbers is the same, right? Here we have 2, here we have 2 also, here we have 5, here we have 5 also. You just consider 1 times of 2. So the LCM will be 2, only write once. Then times 2 times 2 times 3 times 5. We have 2, 5, but we only need to write once. Okay, you will still get 120. Okay, so be careful when you do the prime factorization or repeated division because they look quite similar. Okay, now in this video, let's focus on HCF first. So in the next video, I will talk about LCM. Now, I think this one you should be no problem. How about you try yourself? The answer will be 6 meter. Okay, you can pause the video and try yourself. Now we try this one because this number become larger. When the number become larger, it's harder for us to do it, but we can use our calculator to help us do the prime factorization. Liu has 6,930 red candies and Bing has 13,923 green candies. They want to pack the candies in such a way that each box contains equal number of candies. And also, each box should have only red candies or green candies, means that they cannot mix. One box only can has red candies or green candies, cannot mix red and green. And every box need to have same number of candies. That means if this is 12 candies, every box need to have 12 candies. Okay, what is the greatest numbers of candies that can be packed in each box? So here I'm not going to use a distinct method because number is quite big, right? So if I want to get all the factors of 6930 and all the factors of 13923, it will take time. So here I'm going to use repeated division or prime factorization. So let me show you prime factorization first. So some students always mix up, they don't know when do we use highest common factors, when do we use LCM. So when you see you have a number of things and you want to separate them into a smaller group, in this situation, we will be using factors, right? Why? Let's say you have 20. So the factor of 20 is 1 times 20, 2 times 10, and 4 times 5. What does this mean? These are all the factors of 20. This means that 20 can be divided into 1 group, 2 group, 4 group, 5 group, 10 group, and 20 group. So whenever you have this wording problem and you don't know to use HCF or LCM, try to ask yourself, do we have a great number of things and want to separate them into a smaller group? So if that's the case, normally we will use this highest common factors. Okay, now we have this large number of red candies and green candies. We want to separate them into many boxes. Every box needs to have same number of candies, and we want to find the greatest number of candies. So we know that we will need to use HCF, right, to solve this question. Let me show you prime factorization first. Since this number is quite big, this time I'm going to use our calculator to help us to do the prime factorization. So 6930 equal, then shift, do the prime factorization, press this button. Okay, so it's equal to 2 times, I don't suggest you to write 3 square. If you see 3 square, write 2 times of 3. And then 5 times 7 times 11. Okay, so how about 13923? 13923, quite a big number. 13923 equal. Okay, same things. We want our calculator to help us to do the prime factorization. Shift, press this. Same thing, you see 3 square, don't write 3 square, write 2 times of 3. Okay, so now this is HCF, right? So we look at common number, common factors. Okay, 3, and then we have, okay, here we have 1 3, here we have another 3, one pair, and then we have 7, 7. Okay, so that's all. Now we know that the greatest number of candy can be packed in each box will be equal to 3 times 3 times 7, 63. Okay, so if you don't want to use this prime factorization, you want to use repeated divisions, you also can do it this way. Same thing, you can use your calculator to help you to do the prime factorization first. Let me show you. Okay, now you don't know what number to be used here, right? But after you use your calculator to help you to do the prime factorization, you know that it can be divided by 3. We cannot use 2 because this number can be divided by 2, but this cannot, right? So by looking at it, you know it can be divided by 3. This can be divided by 3 as well. So as I told you just now, if you want to be fast, you actually can divide these two numbers by 9. Let me show you. 3, 3, 3, 3. 3 times 3 you will get 9, right? So as I told you just now, if your school, if your teachers don't want you to use this number, they require you to use prime number, then you need to follow. Okay, 6930 divided by 9, 770, 13923 divided by 9, 1547. Okay. Okay, so I have used 9. Next, I'm going to use 7. 770 divided by 7, you get 1110. 1547 divided by 7, you get 221. Okay, we just stop here because it is HCF, right? We cannot continue. When these two numbers don't have any common factor except 1, then we need to stop. If you want to test, let's say you can press your calculator. Let's see, you want to test these two. 110, 110. Do the prime factorization. You get 2 times 5 times 11. How about 221? 221. Press equal, shift, do the prime factorization. 13 times 17. You don't see any common factors here, right? Except 1. So we just stop here. 9 times 7, you will get 63 also. Okay, so that's all for this video. See you next time. Thanks for watching. Bye bye. If you want to purchase this calculator online, but you worry that you will mispurchase a counterfeit product, you can just go to Shopee and purchase from Casio office store. Before this, I bought my calculator here as well. I already bought 2 calculators from this Casio office store. Both are authentic products. There are 3 colors available now: black, blue, and pink. You can click on the link in the descriptions or just go to Shopee, search for Casio office store. In the search bar, just type Casio office store. Click on it. This is Casio office store. So if you purchase your calculator here, you don't have to worry about the authenticity of the product. Just click on it. You can type the model of the calculator that you want to purchase here, or just go down here, click on scientific calculator. As I told you just now, for this model, there are 3 colors available now: black, blue, and pink. You will notice that there's another model of calculator which look very similar to FX570EX, which is FX991EX. These 2 calculators actually having the same functionality. What is the difference is, for FX991EX, this is two-way power calculator, means that you can use solar energy or battery. There are 3 colors available also for this model: black, blue, and pink. Let me show you some other differences between these 2 calculators. For FX570EX, this is one-way power you only can use battery. The battery used is AAA battery. If you want to replace the battery, you need to take out 6 screws. 1, 2, 3, 4, 5, 6. For FX991EX, this is two-way power calculator. You can use solar energy or battery. If you want to change or replace the battery, you just need to take out 1 screw. The battery used in this calculator is button cell battery, LR44. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye.